So today we're going to talk about the Pythagorean Theorem, which is a way to figure out the hypotenuse of a triangle. So the theorem goes a squared, a is a side length, b plus b squared, which is also a side length, equals c squared. C is the hypotenuse. Another way to look at the Pythagorean Theorem, which is simply square rooting both sides, is the square root of a squared plus b squared equals c. So this is all nice, but what really helps visualize something is a picture. So let's draw out a little picture. So this is a 90 degree triangle. I'll just give some practice. So let's say that B is 3, and let's say that A is 4. So here we have our two side lengths, A and B, and we're trying to find the hypotenuse. So we can use a squared plus b squared equals c squared to find this hypotenuse. Hypotenuse is just the side opposite the 90-degree angle. So let's plug in the stuff we know. A squared, that's 16. B squared, 3 squared is 9. So if you add those two together, you get 25. Now notice, 25 is not c. 25 is c squared. So we're going to have to square root both sides, right? So we get c equals 5. Okay, so now let's look at the reason why Pythagorean Theorem works. Let's draw out a bunch of little squares using the side lengths of the triangle, right? Okay, so pretend they're squares, they're not very uniform, whatever. So, in a square, if one side length is one number, all the other side lengths have to be that same number. It's like the rule of squares. So this is 4, this is 4, and this is 4. Now to find the area of this, it's going to be base times height, which is 4 times 4, 16. Now, this one, the same rule applies. Everything is 3 because one side length is 3. 3 times 3 is 9. 5, all side lengths are 5. 5 times 5, 25. Now, do these three numbers look kind of familiar? If you said yes, you should notice that this makes sense, right? This should make sense because if a squared plus b squared equals c squared, and our side length, when made into a square, are a squared, that's 4 times 4, that's the same thing, so that's going to be 16. B squared, 3 times 3, that's going to be 9. This is what this is saying. So you can see that you can get this area by adding up these two squares, the area of these two squares, right? But if you want to find c, this hypotenuse, you're going to want to take the square root of both sides. So you're going to get square root of a squared plus b squared equals c. So if you plug everything in, you're going to get c is 5. And that's why the Pythagorean Theorem works. Okay, so now let's do an example problem. So here we are solving for a. So in this case, we're going to have to take the Pythagorean Theorem, which is a squared plus b squared equals c squared, and we're going to have to rewrite it so that we're solving for a, or a squared, right? So here we have b squared. And we know that this is b because this side length, this hypotenuse, I suppose, is going to be the longest of them all. It's going to be the one across from the 90-degree angle. So we know that this is c. This can't be c. It won't work that way. So let's rewrite it. Let's subtract b squared from both sides to solve for a squared. So a squared equals c squared minus b squared, right? Now let's just plug in the stuff that we know. So we don't know a squared, so we're just going to leave that be. We know c squared. 13 squared is 169. Now b squared is 25. So 169 minus 25 is going to be 144. Now to solve for a, which is what the problem asks us to do, we have to square root both sides. So we get a equals 12. So that's how easy it is to solve for side lengths or a hypotenuse using the Pythagorean theorem.